first attempt at a video solution. So information we've got in the question, we've got the mass of the bob, which is this bob here. We've got the length of the piece of string, which is also indicated here, and we're told that it does 120 revolutions per minute. What's the tension in the string? Okay, so relevant equations, we're going in a circle, so I'm thinking, okay, F equals mv squared over r, or m omega squared r. We don't know which one's going to be more useful yet. We also know that it does this, 120 revolutions in 1 minute. So if it's doing 120 revolutions, minutes not really useful, so I'm going to convert that to seconds. If it's doing 120 revolutions in 1 minute, it's doing 120 revolutions in 60 seconds, which means it's doing 2 revolutions per second. Omega is not revolutions per second, but radians per second. But we also know that each revolution is 2 pi revolutions. Okay, so the angular velocity is 2 revolutions times 2 pi radians per revolution per second. So in other words, 4 pi radians per second. Okay, now we've got that, we can plot that into there to work out what the centripetal force is. So centripetal force is equal to m, which is, oops, I don't want to write that, 0.5 times omega squared, so that's 4 pi squared, so that's 16 pi squared, times 0.45. 0.45, there we go. Now if I plot that into a calculator, I get 35.5 newtons. That's not the tension in the string though, that's the centripetal force, which if you recall is the resultant force accelerating this in a circle. The tension also has to balance the weight of this object before it provides the resultant force. So if we add to that the weight of the object, then that will give us the tension. Okay, so the tension is equal to the centripetal force, I'll call it FC, the centripetal force, plus the weight of the object. Okay, remember the centripetal force is the resultant force of all the things acting on it. So if I was to draw over here, we've got tension acting upwards and we've got the weight acting downwards. So the resultant of those is T minus mg, because we want the resultant acting towards the centre. So the centripetal force, the resultant force, is T minus mg. If you rearrange that, we get that T is the centripetal force plus the weight. Okay, so 35.5 newtons plus 0.5 times 9.8, put in brackets to make it clear, which gives us 40.4, which to 2 significant figures, all these bits of data are to 2 significant figures, to 2 significant figures is 40.